We learned about functions. Now it's time to again apply what we learned. And for this, we'll revisit this BMI calculator we worked on earlier in this course, and we'll again apply what we learned to break up the code we have in this BMI calculator and split it into multiple functions. So that in this module, we do practice how we can write custom functions by splitting up that big main function which we got at the moment. And whilst doing that, we'll also see an example for how functions help us reuse code and why we use functions in the first place. Now for that, we'll continue working on that BMI calculator code we worked on before in this course. And in case you skipped that module or you don't have the code at hand right now, attached you find my code snapshot with that project as we left it. And of course, I want to say it right away, this project could stay the way it is. It works just fine, but of course we have a rather big main function, though of course it depends on how you define big. But this main function does multiple things. And as a general rule of thumb, you want to try to write functions that only do one thing each. I do have a complete course about writing clean code, which applies to basically all programming languages, and I do talk about that there as well. And this function, this main function at the moment does not do one thing, but it does all the things we do in this application overall. It prints some information here, then it gathers the weight and the height inputs, it does conversions, or it cleans the input and then does conversions, and then it does the actual BMI calculation. And therefore here we can certainly split up that function into multiple smaller functions to split that workload. Now, definitely feel free to try doing this on your own first. Come up with a couple of functions you could write on your own, and then move the different functionality into those different functions and make sure you glue them together in that main function again then, possibly using parameters and return values where needed. You can even try to split your custom functions across multiple packages, but that's totally optional. Now, in the next lectures, we're going to split that up into multiple functions together, and then you can always compare your solution and your approach to mine to see how I solved this. Now, to split that up into multiple functions, let's first of all identify the different workloads we have here to find out what we might want to split up. And we could, for example, put this general information into one function that we call. Then we could put the logic for fetching weight and height into separate functions. We could even put that logic for reading user input in general into a custom function. And we might want to put that cleaning and parsing step into a separate function. And then, of course, we also might want to put this BMI calculation into a separate function, so that if the formula would change, which it of course won't, but if it would change, or if we would change the code somehow, and we would be calculating the BMI in different places of our application, we only have to change it once, instead of having to search through all our code base and changing the formula in different places. And then last but not least, of course, this output here could also go into a separate function. And therefore, I'll start here at the very top with outputting that information. For that, I'll add a brand new function. And since we already have a separate package called info, I'll put that function into that package. Not something which you have to do, but something which might make sense given the fact that we have that package already. So in this info.go file, I'll add a new function, which I will name print welcome with a capital P at the beginning, because this function should be callable from outside this package, so from inside other packages that import this package. And it won't take any parameters, it doesn't need any input, and it also won't return anything. But instead, inside of this function, I just wanna use the format package. Hence, we have to import format here in this info.go file. And then here execute the println function, which is built into that format package, and print the main title, which we now actually can convert back to a lowercase m at the beginning, since we only use it inside of this info package. We'll not use it in other files anymore in the near future. So here I'll refer to main title with a lowercase m. And then I'll also print my separator, which now also can be transformed to start with a lowercase s, since I'll only use it here in this package. I'll keep wait prompt and height prompt the way they are, since at the moment they are getting used outside of this package as well, and hence I only added this function and changed these two constants. Now back in bmi.go, instead of having these two lines of code here, we can use our info package, which we are already importing here, to call that print welcome function like that. So we still call a function like this if it's from another package. The only difference is that we refer to that package and then use this dot notation to access the function in that package which we want to execute. And that's step number 1. That's my first custom function using what we learned before. As a next step, we might want to gather the weight and height inputs. And for that, I'll add another new function, maybe in that same file or in a different file. The input.go file might be a suitable file given its name, which is part of the main package though, and that's fine. We could also turn it into a separate package, but I'll keep it as part of the main package. And in there, I'll add a new function, which I'll name getUserMetrics. Again, the name is up to you, but you should describe what the function does, and this function should deal with fetching the user weight and height inputs. So that should be a good name. And for this function, I don't expect any parameters, but we'll have return values, and actually we'll have more than one return value. We'll have a weight and a height. So we will return two values, and therefore we have to specify those return values here, or their types to be precise. You learned that if it's more than one return value, we have to wrap the list of return value types in parentheses here, and that's therefore what I'll add. And then we have our curly braces with the function body. But which return value types will we have in getUserMetrics now? Well, that is up to you. We could return the fetched weight input and height input strings, and then continue with cleaning them and so on in the next steps in the main function. Or we could argue that actually the getUserMetrics function should already do the cleaning for us and should therefore return the floats in the end. And that argument would make sense to me, that getUserMetrics should return floats and not just the raw user input. And therefore I'll return two float64 values here. And then inside of getUserMetrics, I'll execute this code here. So I'll cut that code from bmi.go and add it here in input.go. But of course, for that to work, we need to make sure that we again import format and info here. So I'll click on format, go to the light bulb and add the format import, and do the same for info. So that's now also imported. Now I then get my weight and height input, and then I can return those values, though we first of all have to clean them. So we can go back to bmi.go, remove those comments, and grab those lines of code where we clean the input and parse the float from the input text, and cut that from bmi.go as well, and go back to input.go and add it here in getUserMetrics. And then here we do all that cleaning and parsing, and we should therefore import those packages, strings and strconf, like that. And then ultimately at the end, here at the bottom, we can return weight and height like this. Alternatively, we could work with named return values and name this weight and height here when we define the return value types, like this. And then we don't create new variables here, but instead we assign to existing variables like this. And we can just call return like this, and automatically the named return values, so these two variables, will be returned. Both works, and it's up to you which approach you prefer. Now with that, back in BMI.go, we just have to call getUserMetrics. We don't need to import that from a package or call that on a package, since it's part of the same main package here. So just calling it like this is fine, and starting with a lowercase character is fine since it's the same package. And then we just have to create weight and height here and store the returned values in those variables. Whoops, like that. And here we need the colon equal sign operator because here in the main function we are creating brand new variables. We didn't have those variables before. And with this, if we save that, imports should get cleaned up automatically as soon as we save. We can try running this again, and it should still work fine. And it does. But now we added a couple of custom functions. Still, we can do more. We definitely did split up our code quite a bit, but still we're doing more than one thing in main. We have different levels of abstraction here, as it's called. We're calling some functions, and then we're all of a sudden doing some low-level calculations. We typically want to avoid that. And in input.go, that getUserMetrics function is also still rather big. We could make an argument for breaking that up even more as well. And I want to do both. Make BMI.go simpler and break up the getUserMetrics function more. Now I'll start with BMI.go. And first of all, I want to outsource this formula. Here I'll create a function in the same file, since it makes sense to have the formula for calculating the body mass index in the file called bmi.go, I would say. So here I'll add a new func and name it calculate BMI, because that's what we're doing. And I expect to get two input values here, weight and height. We need that in order to derive the body mass index. So here I'll add weight and height as parameters. The names are up to you though. They don't have to match the variable names up there because we won't have access to those variables in this function anyways. So these names are really totally up to you. But weight and height describe pretty well what will be stored in there. And we definitely do have to define the value types of those parameters. And here I expect to get float 64 values. So I'll add those type names after the parameter names. And then we can grab that formula, cut it, and instead just return it here. Using weight and height, like this, and making it clear that calculate BMI will return a float 64, therefore, by adding float 64 as a return value type after the function name and parameter list. Now here back in main, we can just call calculate BMI and pass in weight and height like that. And now I'll also remove the comments to make this all a bit more concise and shorter. So now we outsourced this into this function, and the advantage, as mentioned before, would be that if we would call calculate BMI in different parts of the application, and we ever want to change this formula, we only have to do it once inside of that function definition instead of having to go into different places in our code and adjusting the formula in all those places manually. This can save you a lot of time as your application grows. Now, as a next step, I also want to outsource this line of code here, line 16, and put that into a separate function. We could do that here in the bmi.go file, but where calculate BMI made a lot of sense to reside in a file named bmi.go, just printing some output could possibly also go into another file. Though of course we could also add the function here. You can always have a discussion about that, and it always comes down to personal preferences. But since we have an input.go file, I'll also add an output.go file here, which should be responsible for outputting the results of our calculation. And I'll add that to the main package as well. But in there, I'll add my function called print BMI. And I expect to get the BMI as a input, as a parameter. And it should be of type float64. And then that code, which we have in bmi.go, this line of code will be extracted from there, will be removed from the main function, and instead will be added into this print BMI function. Here we now just again have to add the import of the format package. And with that back in bmi.go, here in the main function, we can just call print BMI and pass our BMI to it. If we now save that code, the format import gets removed there because we're not using the format package anymore in this bmi.go file. And we now have a very lean bmi.go file in general. Only 19 lines of code, and that includes all those blank lines which are added for readability. That's not too bad. And with that, I'm quite happy with the bmi.go file. I'm happy with output.go, but I definitely want to revisit input.go and talk about getUserMetrics. Because whilst we also could leave this function as it is, it's definitely not super complex, we could also argue that this should be split up as well. And that's therefore the last thing I want to do in this course section, to dive even deeper into functions and gain more practice working with functions. In input.go, this getUserMetrics function could be split up into a function that fetches the weight input, one function that fetches height input, one function that cleans weight, one function that cleans height, and so on. But splitting this into 6 different functions or more does really not make too much sense to me. Instead, I would say it's quite interesting to think about what this function does in other terms. Instead of thinking about the steps fetching, cleaning, and parsing, we could also think about weight and height. So we could say that cleaning and parsing weight is all one step combined with getting that input in the first place. And the same is true for the height. Now we only have 2 steps here, which we could outsource into separate functions. And if we take a close look at that code here, we have a prime example for creating a function that can be reused. Because in the end, we perform exactly the same operations twice. And having code duplication as we have it here is never a good idea. You always want to avoid it so that you write less code and you have less code that you need to maintain. Therefore, I'll add another function in here in this input.go file, which I will name getUserInput. Now, this function should in the end perform all these steps. So I'll copy that and add that here. But of course, we now need more generic names. Because now, for example, it's not the weight input, it's the user input in general. Because we'll use that same function for getting both the weight and the height. So here I'll not name this weight input, but just user input instead. And of course also here and here and here. And therefore that here is not the weight, but instead just the entered value or anything like that. Whatever name makes sense to you. And that's what I ultimately want to return here, the entered value. Now, of course, here I am always printing that wait prompt though. So that's still wait specific and not very generic. To make it more generic, we could accept this prompt text as a parameter of type string and just output that here. So output this prompt text here with print. Now we get that from outside when that function is called. Then we perform the same steps no matter if it's about the weight or height, which makes sense because we parse the values and clean the values in exactly the same way. And then we return the entered value. And since we return a value, we should also specify the return type here, and that's of course float64. And here I now also should create entered value and add my colon here, therefore, so that this entered value variable is created. Alternatively, of course, we use named return values by wrapping this into parentheses and giving this a name of entered value, or maybe even just value, and then removing the colon here and referring just to value here and remove it here in that return statement line. That will do the same thing. It will parse that float in the end and store it in this value variable, which is declared right at the start, initialized to its null value, which in case of a float is 0.0, and then we'll override it with that parsed float value and return that value ultimately. And now we can use that getUserInput function here instead of having these large code blocks twice. Here we can get rid of that, and instead we just get our weight here by calling getUserInput, and to getUserInput I'll pass info.waitPrompt so that we show the appropriate prompt text. We expect that input parameter here in getUserInput, hence I pass it in. And waitPrompt is a string, this constant string specifically, and hence we fulfill the requirement of passing in a string. Then we get back a float, and since we prompt for the weight first, we know that this will be our weight. Well, and then we can just copy that and repeat this for the height and store that value and use the height prompt here. And now we can get rid of that code as well, and then just return those values. And that's now a better approach, I would say, and it's a good example for why we use functions in the first place. If we ever change our parsing or cleaning logic or how we read user input, if we want to react to a different character than the enter key being pressed, we only need to do it once here in this getUserInput function, and it will then change for both places where we call that function. Because here we are using the big advantage of functions, which is that we can call functions multiple times with different inputs and getting back different results. And as a developer, you should always strive for solutions like this, where you have as little code duplication as possible, since that will make your code easier to maintain and it will make it easier for you as a developer to change your code. And that's it for this section. You could definitely come up with more ideas of splitting this up into functions, either splitting it differently or maybe even splitting this into more functions. But you definitely don't want to reach the point where you put every line of code into a separate function. That's not the idea. Nonetheless, you saw some advantages of functions in this section, like here, the removed code duplication. And in general, we now practiced in detail how we can work with functions, with function parameters and return values, including named return values, and how we deal with functions in general. I can only encourage you to play around with that even more, build your own other demo projects, or dive deeper into this project and maybe put some functions into separate packages, or come up with different ways of splitting up those functions. For the moment, We are done with this though, and we're ready to move on and now dive into more exciting Go features.